So, with no further ado, I'm going to hand this over to the devil.
Good evening. Thanks everybody for coming out this evening, especially those of you who brought robots. So, 13 years ago, some of us were lamenting the lack of robot building within the club, and we observed that building activity increased with contests. And we knew that there were dozens of small robots collecting dust on the shelves and so forth. And so we were lamenting the lack of building activity and wanted to do something. And at the time we were meeting at the Castro Middle School, and there were a lot of tables around. So we thought, well, let's do tabletop soccer. That would be non-trivial, was most of the comments. We thought, oh, we could put nets around the table, but to catch the robots if they fall. But that would be set up, and we wanted to get away from these, mazes that you had to file away and keep track of, and fixtures and so forth. And that's when it was born, the TableBot. A TableBot is a robot that plays, survives, and lives on a table or pays the price. And so the concept is that how do you get there? You get there in phases. The first phase is to have the robot go from one end of the table and back. The second phase is to have the robot push a block off the edge of the table. And the third phase is to move the block into a shoebox mounted at the end of the table. Now, we knew we had all these robots that you guys have built, demonstrated one time, and kind of set it back on the shelf collecting dust. So we don't specify the size of the robot, the type of the robot, anything. It's just like, bring your robot. Have it do phase 1, have it do phase 2, have it do phase 3. And I've seen some awful large shoe boxes up here. People mounted it. We don't specify the table either. It's all about the show. This is not a contest. This is a show. Without a deadline, nothing happens. And so that's why we've done this. And the idea is to get your robots out in whatever state they are and show them off. The very next year, we open this thing up to not just be TableBot, but the HBRC Challenge. The concept is to bring your robot, whatever type it is and whatever phase it is. Actually, you're supposed to bring it in finished in June, but are you ever really finished with these things? And enunciate what it is you'd like to do for phase 2 and 3 in August and October, but it never works out. The long story short is tonight's the deadline. Everybody's brought what they've got, and we'll have show and tell for the whole meeting, and it's going to be wonderful. So to do the TableBot challenge, I'd like to invite up Danny Watson, who's been teaching classes in something called the Challange bot. Danny, take it away.
All right.
Grab the microphone.
Hello?
Thank you. Thanks for that.
Is this working? Do I sound louder to you guys?
Talk straight into it.
Hello? Like that?
That should work if it's on.
Test?
Oh.
Testing? There we go. Yeah. All right, cool. Okay, so this is the portion of the show where we run TableBots and do the TableBot challenge. Cam, is this yours? Or?
That's not mine.
Okay.
Bonus board.
Yeah, and we have a Raspberry Pi 2.8 TFT touch module board.
It's unpopular.
It doesn't, yeah, it's unpopulated. It doesn't look like it would actually do anything. It's just the circuits for whoever wins, I guess. Which is everybody. We're all winners here. So I'll chop this up into very small pieces and have it on your way out. All right, so anybody who is here and they have a robot that can go from one end of this table to the other and back again, please bring your robot up. Is there anybody who's doing that? Oh, there is. Okay, cool. 2 people. Cool. How about
Madeira, she's stiff competition.
All
It's
right.
not a contest. Yeah.
tough act
Yeah,
to
they
follow.
did this for like about 5 5 months or so.
All right, that's awesome. Can you tell us a little bit more about your robot as you set it up?
It isn't, somebody just said it, but this is actually called a solar tank, since pretty much this is called solar. This is pretty much a tank shape sort of thing.
Okay.
And it could actually like pick up a toilet paper roll like that's been used. Like there's no more toilet papers on it.
I think she means just the cardboard part.
Yes, just a cardboard part. So it could go there, detect the object, and go back. And if it misses it, it's pretty much going to just jump off the table.
So right now is it on the setting where it'll just go to one end and back again? It doesn't expect.
Yeah.
You need an object, can you use something like this? Here?
Or we can give it an object.
I squished it.
I don't know.
Can we give it a try?
Let's find out.
I need to make it thinner. You got different code in there?
Uh-oh.
No, I just remembered I can't do the code because we just did a code and now it's pretty much just set to that. I'm so sorry.
Oh, that's all right. That's all right. That's okay. Anybody else?
I'm so sorry that I wasted your time. I'm so sorry.
Oh, it's okay.
Did you reprogram it?
Can.
We got the club bug.
All right, cool. We got.
Club bug, class. Oh. Conrad, you
Quite
don't?
a lot.
You have quite a lot.
Quite a lot to bring.
Are you ready to go? Okay, go ahead.
I have. Well, first I have quite a lot.
Well, okay. In the meantime,
Looks like a robot.
oh yeah, I can do the robot.
That's for the robot dance party.
So Carter brought his for show and tell, actually,
Yeah.
not for
Not for demonstration.
Oh,
well, he can show.
It's
off.
okay.
Yeah, yeah.
Okay. Do you want to talk about your
It's okay, go ahead.
adventures with this?
Yeah.
You want to talk about it?
Okay.
So, first what we're going to talk about is how this was built. First we started off with a Viper kit with this bottom piece of metal for a robot competition, and as you can see it's kind of beat up right now. So they wouldn't allow that for the next time, so we replaced it using a jigsaw, sawing this plastic to pieces. So we used a jigsaw to cut this piece of metal into polycarb. I will turn it on in a few minutes. So we use this glue first to seal it up when it first got broken. Well, what we did is we glued this up. So before we added any of the inside parts, where we made this bottom for we made that and it dried for a day, and then the next day we just added all this stuff on. So we drilled some holes the next time. I also 3D print a set of spikes that got torn off when it was 3D printed, so that's fun. And after that, after if this first got torn apart, we actually put glue inside the holes on the bottom. Not sure if you can see though.
Yes, Carter, what competition did you build that for?
Oh, it's a fighting competition.
Should we show them a video?
Yeah, sure. You can.
Looks like it's showing. Oh, yeah.
So this is one of
So
them.
show them your trophy.
Oh, yeah. The first time I fought with this metal one, I got
So this was at Fetch Robotics.
yeah.
Fetch
Is that
Robotics
a
has a
place
little
in
employee
San?
competition.
Is that a place in San Jose?
Yeah, called Fetch Fest.
Yeah, and it was a fighting competition. So what you're gonna see here is my robot first getting torn apart by this spinner. Alright.
Okay,
So
we have Banshee, we have Fireball.
Lots of people.
Ready?
Three,
Oh, we should go ahead, come on.
3, 2, 1, fight! So,
Sorry. Don't apologize.
it got torn on a Saturday.
So basically, we learned that, what did we learn about polycarbonate and glue?
It does not work. So what we did to keep it together, surprisingly, it came back the way it was. So we put glue in the holes to
There.
keep this in, and it was not good. So surprisingly, nothing on the inside was broken, just the plastic just completely fell off because the glue isn't strong enough to hold by itself. So we put glue in the holes of the drilling that we use with the special one of these drills.
So then we reinforced it with screws.
Yes.
And we're back to
then-
battle again.
So yeah, and then I got some tear in the wheels. Then my second fight, when it was all back together, I got torn again. But I think what was the problem was one of the sides on the left or right. I can't exactly remember, but I guess we didn't hold it. We didn't glue it good enough, and then it got cracked.
I think that was good, bud.
It got cracked.
I think that was good.
So then we replaced everything, and now it's here.
All right, thank
Any
you.
questions?
Can you drive it around
Yeah, yeah.
Yes, I can. Actually, I can.
safely?
Yes.
Hey, can you go from one end of the table to the other and back without falling off?
I think you can.
Probably.
All right.
It depends on.
Depends on your driving skills, doesn't it?
Well, I'm a pretty good driver, so.
We'll see. Yeah.
I guess it counts.
Yeah, it counts. There's no rules against it.
So.
Wow, it's fast.
So.
All right. Yay. Put it back on the table and see if it still runs.
It still runs. Don't worry.
Let's see. All right, that's phase 4.
All right, thank you.
What is the microphone?
It all depends on the driving skills.
Okay, thank you very much.
Thanks, bud.
So, what was your name again?
I am Carter Hickman.
Thank you, Carter. Does anybody else have a robot that they want to show? Tablebot?
Yeah,
Is this also show and tell?
table bot.
Just Tablebot? Okay.
Just table bot.
Anybody Tablebot? I have a Tablebot. You can show your table.
All right, this is the club bug. I think he's about 5 or 6 years old. Anyways, ooh, I got a block somewhere. Let me get my block. All right, Steve. Steve, okay, ladies and gentlemen. All right. Straight shot. See if we can do this. Oh, no, I forgot to change the battery.
You can only make it out of plastic, so. The second time I was against this one, so it was no help. It was a different small
So this is an Arduino with 2 continuous rotation servos, a couple of infrared sensors facing downward. I've got some snap action switches for the bumper, and then an ultrasonic here. So if he happens to get this thing into the bucket, into the shoebox, he'll push it in and turn around. Here he's going to push it off the end. Thank Thank you. All part of the show. You're very lucky. This doesn't happen very often. You folks are too easily amused. Just about you.
The sonar says you're pointed too low.
Yeah, it is, isn't it? It's pretty sad, the way we don't respect our robots like we should. Spend some time cleaning them up, dusting them off.
Poor robot.
It's not a contest, it's a show. Any more table bots? That's your line, Danny.
All right. I will. Testing. What's that noise? Oh, okay, cool. Hello? All right. So I have a table bot as well. And it is also Arduino based. There's a literal bug on the table. So I'll do it the short way for.
It's going to ruin your programming.
It's going to ruin my programming. Yes. Oh no. Yeah. All right, cool. So this is also Arduino based, just like Camp's. Whoa, that was close. And this is the robot that I teach. He was mentioning that I have a Challange bot class. It's very heavily influenced by this Challange here. I took a class that was taught by Wayne Gramlich. I think that was like 2 years ago now. It was a while ago. And since then, I have taken the robot and the class and done a lot of work with it and taught it to a lot of people. How do I switch this? I want to switch to my laptop. Oh, I just say it and it happens? Oh, okay. That's pretty cool. That way? No. That way? Yes. All right. So that's. This right here is the web page, challengebot.com. And if you want to sign up for classes, there's one next weekend, next Sunday. It's two 4-hour sessions, and you go from 0 to a robot that does this. So if you or anyone you know wants to build their first robot, we'll bring all the tools you need. You'll get all of the hardware, and you can go to this website for contact info. Down at the bottom, you can see that it says my email, and you can sign up by emailing me. That's how you'll reserve a spot. So it's 2 Sundays in a row. Yep, that's the short version. If you want to hear more, come talk to me, and maybe let's go on to the next part of the show. Camp?
Okay.
You're on.
I'm just discussing mapping here with young Carter.
Okay, so I can
Sorry.
babble some more.
Yes, yes, please.
All right, cool. So, I do other things as well that are totally not robotics.
This is specifically a robot form, and I've been in the person out there.
I guess I could show the other robot.
I'm actually mapping the room here real quickly, if you don't mind, so that I can use that as part of the 4-bot challenge demo.
I see.
Soon to be coming up. Yes.
So the same robot, the only difference between this robot and this robot is the programming is slightly different. And the sonar sensors, rather than being pointed downwards at the table, they're pointed forwards. And so hopefully if this works, it looks like it's following the box using just 2 sonar sensors. And in a sense it is. It's very easy to trick though. So yeah, that's the other thing that we do in the class. Are you done?
Yeah, okay.
Oh, questions from the back?
Oh, questions, go ahead.
I have a robot.
Oh,
While we're waiting.
okay, sure.
Table bot?
Runs on a table.
Go for it.
All right, come on up. Oh.
Takes a little longer than our house. You guys are so kind.
Okay, Brian, if you could zoom in. So this is a robot that we at Ologic worked on with one of our customers. We designed the electronics and the customer designed the mechanical apparatus. And the reason I'm showing it is because normally when we think of robots, we typically think of wheeled robots or sometimes maybe a 2-legged robot. But this robot has a really novel mechanism that uses 2 motors to drive these rails. I keep moving. There's essentially 1 rail on each side of the robot, and 3 legs on that side are attached to the rail. And when the rail moves, you can see how the legs move on a pivot, such that when the front and back legs move up, the middle one moves down. When the middle one moves up, the front and back move down. And by alternating that mechanism, the robot can move forward.
Is that 3D printed?
This is I don't believe it is 3D printed, but it is a plastic material that's it's cut out of a flat sheet. And then it just folds up like origami and it's held together with ribbon. So it's also very, very durable. You can throw it off the table. Or, so I just wanted to show you the mechanical mechanism, and let me see if I can make it move here, so you can get a feel for what it looks like. It's very, actually kind of creepy. It looks like an insect. So I'm going to put the microphone down.
Made for. Very soft. So isn't that,
Can you pick it up and turn it around and send it back this way?
isn't that the one from Berkeley?
Yeah. Yeah, I am driving it. So anyway, this is a. I'll have it around after the show and tell if anyone wants to take a look at it. The company that's making this is called Dash Robotics, and it's not it's not really available yet. They have a Kickstarter going on, but hopefully you'll be able to buy it.
Just
soon.
RC or is there a microprocessor?
There's a Nordic Bluetooth chip on here, which has the Cortex M0, so that's the microcontroller, and it's talking to the iPad. Thank you. Pardon?
What is it called?
The company is called Dash Robotics, and they have a name for this robot. I think they call it the Kamigami. Kamigami. I don't know what that means. Somebody's laughing. You must know what it means.
Oh, you said it.
Okay. It must mean something, but anyway, I'll have it if you want to take a look at it later.
So what kind of electronics it has? What electronics it has?
What microprocessor?
Oh, the microprocessor is a Cortex M0, which is kind of the low end of the Cortex lines. I would call it more powerful than an Arduino, kind of like one step up from Arduino programming. The processor is made by Nordic, which also happens to make the Bluetooth. So it is a combination of Bluetooth, Cortex M0 chip, and that's the electronics on it.
Okay, so now you see the robot driving down the aisle of this map that I made. It's a little whacked, but you see it driving down the aisle. Nothing up my sleeve. I'm remote controlling it, yes, but you see it's generating a map as it's driving along. And with any luck, we'll bring it back, and that maybe count for 4-bot points. The 4-bot challenge is an outgrowth of the TableBot challenge. It too has 3 phases. Phase 1 is to go from one end of the room to the other and back. Phase 2 is to find an object within the room. And then phase 3 is to fetch that object. So here we go. I've made it to the back of the room there. It kind of sort of maps out. Let's do this. It's a good thing you folks are easily amused. Uh-oh.
Trying to understand what I'm seeing in your map there, Cam.
Yeah, well, I'm getting in trouble now. It won't stop. Is it bumping into something?
Yeah.
All right. Pick up the robot. Just pick it up by its handle. It's fine. Actually, yeah, just pick it up. Bear with me. Let's see if we can. Oh, okay. Here we go. Here we go. Bear with me. Bear with me. Oh shoot! I missed it. Okay, I got to get to the teleop twist. There it is. Bang. Okay, stopped. Okay, it stopped. Just stop everything. Okay, so this is a map I've made of this room. It's pretty whacked right here. But I'll give you an example of how the ROS navigation is supposed to work. So I'm gonna bring this robot, gosh, over to this corner. It's probably going to be pretty messed up. We'll see. Maybe I can get it to go through Ralph's amazing maze here. So here we are with, okay, bear with me. I'm going to my cheat sheet here. And I'm going to press the second. I got my mouse back. Okay, don't panic, don't panic. Okay, so here comes the command. Oopsie. Control C, open up another terminal window, and I'm pasting the change to the map subdirectory. And now I'm too bad you can't see this, it's really interesting. I'm running a command, ROS run map server, map saver, to save the map. It's found the map and it saved it. Now I'm going to navigate to, if I can get this thing switching again. Oh, there, it came back here. Very interesting. Bear with me. Okay, I'm going back to the mapping routine, the G mapping. Careful not to kill the wrong window or the whole demo goes to hell. Okay, did I say that loud? So bear with me, here we go. This is the mapping GUI. I have made a map, saved the map. I'm killing the mapping GUI, and I'm going to load in the 2D nav to navigate within the map. Okay, so I've killed G mapping, and now going back to my cheat sheet, I'm loading in the navigation routine, 2D nav. I believe, Ralph, if I'm not mistaken, this is the AMCL, right. Adaptive Monte Carlo Localization. Okay. So here comes the map that I just made, and I may need your help again. Let's see if my mouse here, bear with me. There you go. Damn.
Zoom in a little.
Yeah, you see that?
Well, it's there. I don't have my laser scan yet. Let's give this a second. Say, Ralph. Is there a correlation between the scan thing coming through and the size of the map? Is that going to bug me out? In other words, let's say here, I don't see my laser scan. Actually,
There it is coming.
all right. So if I
What about, what's your fixed screen?
where's my mouse? There it is. Okay, bear with me. So this is the scan topic, and if you look in there, I'm not getting any messages.
Just probably the Wi-Fi in here is so bad that it's going to be.
It's okay. That's okay. It may just be me, but I noticed a higher correlation of the scans going away with a larger map,
There's more data
and I'm wondering if
lost.
that's a valid correlation.
Should be.
Anyways, this is part of ROS. This is some fun stuff we've been doing at the Intro to ROS class. We use the bot vac in the original XD robot. It has an API so that you can talk to the LiDAR through ROS. You've correlated the LiDAR with the odometry, you can create the map. We put a Raspberry Pi in here, and it's like I said, it's got ROS installed. Basically, you cut here with a 12-volt battery, you power the Pi off that, and then the USB out. It also has a little Wi-Fi dongle. USB out of the Pi, talk to the robot through the API. You're able to drive it around and take advantage of the LiDAR. So this has come up. It seems to be all set. Ooh, no, my scanning's coming and going. If this was working perfectly, you'd see messages coming through here, and on the, oh, look at that, it's starting to work. No. Okay, so, oh, this is fun. Where'd the robot go? Oh, there it is. Okay. And so basically, so there you see some inflated obstacles, from all along. It takes the obstacles and adds a little bit to it so the robot has some space to come around. Incidentally, this is a 3D map so that you can also tilt it sideways and look at it. You can see the LiDAR scans. My laser scans are there. Okay, so I've got my local cost map going there. And so let me hit here. Okay, so there's the robot. It's sitting at that corner there. Basically the way it works, and it's a pretty ugly corner. Telling me somewhere different. So you set the pose. I'm going to come over here, and I'm actually going to set the pose there. The robot doesn't know any better. Like I say, that corner is pretty ugly. But the robot should flip over there in a second. Okay? And let's, let me move this over a bit. Okay? And open this up a little more. And move it over a little more. Okay. So basically, now that we've done all this, we'll say 2D nav goal, click. And you come down here and point, press, and drag. Oh, shoot. And the robot will navigate there. My finger slipped. I actually I didn't want to go there. But as you can see, the robot's starting to move. Nope, he's not moving because he's not getting his scans here. So now he's doing the this is the whirling dervish. Yeah, that's the whirling dervish there. He spins around to try and get his bearings. My map goes flying around. And the status here, I think I'm out of time on this. If the status catches up if the scans catch up one more time, I'll try to navigate again, but it's not, oh, there it comes. Oh, shoot. Oh, here we go. 0, 0. Thank you. Okay. Let's go 2D nav, and let's navigate to there. And no, my laser scans have gone away again. See, there's a lot of stuff going on here. Ralph, this is what I wanted to show. Okay, this goes the whirling dervish again. So Ralph, check this out. Ralph, you out there?
Yeah.
My fixed frame. When I change my fixed frame to laser scan, laser base link, you see those scans come through just fine, right?
All right, so the transform timing is causing it to drop out.
Okay.
There's a timing synchronization between.
Okay. All right, I'm going to wrap up this demo anyways. That was an attempt at the Floorbot challenge to go from one end of the room to the other. It didn't quite work out, but we'll be back. All right, so